Hello everybody and welcome back. In this video we're going to solve a problem from section 7.6. 7.6 is all about solving radical equations. So let's just jump right into it. So to solve this problem, the first thing we need to do is, just generally speaking, you want to isolate radicals. So with that goal in mind, let's subtract 5 from both sides. This is going to leave us with x minus 5 is the square root of x plus 7. Alright, so now now that we've isolated this radical, we want to eliminate it. We want to get rid of the square root. Well, generally speaking, to get rid of square roots, we square both sides. This gives us x minus 5 squared. Remember to use parentheses. And then if you square the square root of x plus 7, I'll write it out. But what's going to happen is this is just going to cancel out. The square root and the square just cancel. You're just left with x plus 7. On the left side, remember that in general if you have a minus b squared, something like this, it's just the same thing as a squared minus 2ab plus b squared. So you can use this formula here. This would be x squared minus 10x plus 25. Now we've got this quadratic equation, and remember, whenever you're trying to solve a quadratic equation, you should get it equal to 0 and attempt to factor. So in doing that, we would subtract x and subtract 7. This leaves us with x squared. Here we've got minus 10x and minus x. That's minus 11x. We've got plus 25, and we got minus 7. That's plus 18. And then on the right-hand side, we've just got 0. All right, and then we just have to try to factor this now. Focusing in on the fact that we have 18 right here, we need to consider the factors of 18, which would sum to negative 11. Well, if we have the factors of 18 that sum to negative 11, well, you got 1 times 18, you got negative 1 times negative 18. I suppose we should only really consider the negative pairs, but nonetheless, these are all of the possible factor pairs here, right? So now we just need to take the one that actually has a sum of minus 11. Well, that's this one right here. So we just get x minus 2 times x minus 9 equal to 0. And there we just need to set each of these factors equal to 0 by the zero product property, leaving us with x equals 2 or x equals 9. All right, now a point I want to drive home here is that we started off with this equation right here. Maybe I'll label it. This is equation 1. We started off with equation Roman numeral 1. And then we got equation 2 by squaring both sides. Note that if you square both sides, you won't necessarily, just because you get a solution in equation 2, it doesn't mean it's necessarily a solution of the original equation, equation 1. So basically what I'm saying is we squared in this step here, and that gives us these solutions, but they might not necessarily be solutions, solutions to equation 1. So we need to check that they in fact are. Let's go ahead and check them. Well, if we check x equals 2, we're going to check x equals 2. For x equals 2, we would have, remember we're checking equation 1, we get 2 minus 5, I'm going to put a question mark, equals the square root of 2 plus 7. Well, notice on the left-hand side we've got 2 minus 5, that's just minus 3. And then down below we've got the square root of 9, which is just 3. But notice these are not equal, right? So we have a contradiction, so therefore we can disregard x equals 2. So contradiction, oops, off the screen, sorry about that. This is a contradiction. So we can throw out x equals 2. Let's check x equals 9. Maybe there's still hope for x equals 9. If we check that one, we would, again, we're checking equation 1, so that would be 9 minus 5. We're checking whether that equals the square root of 9 plus 7. On the left-hand side, 9 minus 5 is 4. On the right-hand side, we have the square root of 16. Is the square root of 16 equal to 4? And the answer is yes. So 4 equals 4. We get a true statement when we go to plug in x equals 9. Therefore, x equals 9 is a solution. X equals 2, which we checked and we got a contradiction. That means x equals 2 is not a solution. So this is the only solution. So anyway, that's it for this video. I just wanted to show you an example of solving a radical equation and just really hitting home the point that just because we squared both sides and got these solutions to equation 2, x equals 2 and x equals 9, we know that these were both solutions to equation 2. But that does not necessarily mean that they will still be solutions to equation 1. So just bear that in mind, that you need to check your solutions when you do things like squaring both sides of an equation. So anyway, that's it for this video. We'll see you guys all in the next one.